Mr. Everyone, today we're going to be looking at the PWR for HBM's nuclear technique. Now, the PWR can be a bit of a confusing structure because it it's very modular and it can kind of work in whatever shape you want it to be. Now, here's each individual component that you could put in a PWR. This is a nice little example design of a PWR that I have made, but since you can't exactly see the inside, I decided to also kind of cut here, and you can kind of see different slices of how I built it. So the PWR stands for Pressurized Water Reactor. It's a reactor that basically works by heating up a coolant rather than steam directly, and then being able to extract that coolant for whatever devious purpose you have of using liquid coolant. These work much different from other sorts of reactors, especially like the RBMK, because its cooling system has a few more steps in it. So as you can see here, I like making it as a bit of like a checkered pattern. To me, it just kind of makes the construction of the reactor easier, especially for higher power. However, since this is very modular, it's modular both horizontally and vertically. You can build it in whatever shape you want. You can have it kind of twist and turn around wherever your base is. I like having it in some sort of blob with extra funky designs. As you can see, we have control rods between both neutron reflectors, and other blocks, other fuel rods and neutron sources. You can see here that there's a lot of heat exchangers, lots of coolant channels, and we only need one neutron source to set this up. So let's look at what each and every one of these parts do. We're going to start with this guy. This is the access port. You need at least two of them, put them on the sides of your reactor, and with this you can extract your hot coolant and input your regular coolant. This is a pressure vessel. It works as the shell. As you can see here, it needs to cover all the internal parts of the reactor to form the plate to form, and it is the casing. Basically, every single one of these blocks here are pressure vessels. This is the PWR controller. You use it to kind of start up the reactor. See if we can go to this one over here. Once it will be like this. If you click it, it'll form the reactor, and then you can right-click it again, and you'll be able to see the coolant. You'll be able to change what kind of coolant you're using. You can adjust the control rods manually. You can see how much flux is currently in there, how much the temperatures are. You can input fuel and take spent fuel out. Everything that you do is primarily starting right there. This is the heat exchanger. It'll take heat that's generated inside the core of it, the core of the reactor, and move it to the hull or the coolant rods. And these PWR coolant channels will take heat moved there from the heat exchanger, and they will turn those into the heat that is used to heat up the coolant. You need both of these in basically equal measure for your reactor to function properly. This is the neutron source. It works exactly as you think it is. It provides neutrons to your fuel rods. It has a flat 20 flux, and although this in and of itself is not enough to make the core of this really do anything, you can actually try to jumble up a large amount of these neutron sources and make a kind of like a flat looking reactor. I don't recommend it because that's a lot of radium that's probably put to better use elsewhere. This is the control rod. It works exactly as you think it does. You use the controller to control how extended these rods are, and based off of the extension, it will allow a different percentage of neutrons in between fuel rods, in between neutron reflectors, in between all of that, depending on where you put them. Now, for these sorts of things, it's very important where you place them. The neutron source needs to have a direct line of sight to the rods, and the rods need to have a direct line of sight to each other. Control rods that are placed all the way over here won't end up doing anything. They need to be in between fuel rods or neutron sources for reflectors for them to work. And neutron reflectors need to also be in the direct sight of the fuel rods for those to work as well. I like having them in this kind of checkered pattern, like I mentioned before. because it just kind of makes the construction of this much easier. I'll also go over how all of these are made. This is the fuel rod. Each and every one of these holds one fuel rod, as you see here. And so in the design that I have here, there are 26 fuel rods, not including the neutron source, because the neutron source is just kind of where it does. This is the PWR neutron reflector. It does exactly what you think it does. It takes incoming flux and spits it right back at them. And this is a heat sink. Now, I didn't include any of these inside the actual build, but you actually need these to handle some more of the tougher fuels like Scribidium or something else. Now, the thing about these heat sinks here is that although they make your coolant channels and heat exchangers slightly less effective, they do increase the amount of heat capacity by 5%. So here's how you make them. To make the pressure vessel, all you need is concrete and lead. It's very cheap to make, as you can see. And with 4 leads, 4 concretes, you get 4 vessels. We can go over here. Let's go to the access ports next. This is, once again, pretty simple and cheap to make. 4 leads, 4 concrete or ducrete or any sort of crete, and 4 steel pipes, and you have your access ports. Very easy to make. Probably the most expensive out of all of them is the PWR controllers because it requires rubber and integrated circuit boards, but those are also pretty easy to make, and you don't really need much, and you only need one of these for the entire reactor to function. Now, they are the neutron reflectors. All you need is steel and neutron reflectors, which, if you don't know, are tungsten and carbon or coal or coke, whatever you have there. And just like that, you have yourself 4 neutron reflectors. The neutron source is a welded zirconium plate and some radium beryllium billets. If you don't know, here's how you make the welded zirconium plate. You need 2 cast zirconium plates. A heat sink is a bit different. It requires cast copper and cast saturnite. And cast saturnite is actually pretty expensive to make because you need to reform it, which is a very difficult chemical gas to come in contact with. You need to have a vacuum refinery or a catalytic reformer or a pyrolysis oven, and all of these require very difficult things to get, like bismuth or arsenic. Very difficult to acquire, and that's why I didn't include this in the build. I wanted a nice simple structure that could be made very early on in the game, or at least in your nuclear stage. Right over here is the heat exchanger, very easy, you just need copper and motor, and with 4 copper and 1 motor you get 4 heat exchangers. It's very cost efficient, pretty easy to make. Coolant channels are pretty much the same way, just steel pipes and copper plates and you have it. The control rods work a little bit differently. You need steel plates for boron ingots and 1 motor, and you get 4 control rods. And the PWR fuel rod is 4 cast lead plates, 2 welded zirconium plates, and you get 4 PWR fuel rods. Now, all of these are cheap to produce, and that's because you're going to need a lot of them. As you can see, this structure here has just tons and tons of blocks in it. Look at the cross section, there's a lot of different parts, lots of different moving things here. And it can be all too confusing during construction. Pretty difficult to make. The complexity is not only in the actual construction, but also its fuel usage. At maximum power, it burns through fuels pretty quickly, and you need a lot of them to keep it up. Fortunately, the crafting of fuels is pretty efficient. All you need is 2 billets of whatever fuel you're using. Say this is a medium-enriched uranium fuel. You only need 2 billets and an insulator. This works the same way with all other fuel rods, except for certain BFB fuel rods. Any bismuth fuel rod works a little bit different, because you need 6 nuggets of whatever fuel it is. This is a plutonium one. And they also need bismuth and whatever else is in there. Those 2 rods are a bit confusing, but they're very worth it to kind of experiment with if you have the bismuth. Once again, the bismuth is difficult to get. All the other rods work kind of the same way, where it's simple, just you can get behind making these pretty easily because they are very easy to make. The only issue comes when you need a lot of them, And also, if your reactor is producing a bit too much heat, then it's just going to explode. And depending on how you build your PWR, an explosion or a meltdown can be very bad. So we have the entire reactor here, and we have our access ports, but the issue is we don't have any coolant in here, and we don't have any way to extract it, really do anything. So let me show you guys a basic coolant system. They work a bit different from the RBMK's steam system, but they do work similar. So we could use any one of these coolants, whether liquid lead, heavy water, coolant, even perfluoromethyl or other coolants like that. However, a unique part of the PWR, not only its shape and its fuels, it also can use the different coolants have a flux multiplier. Heavy water will increase the core flux by 25%. This can be good if you're looking for a specific kind of little build for it, but it can also be dangerous because even more flux, especially a 25% increase, can prove bad if you don't know what you're doing. For some reason, you can also use mug root beer, although that is a bit of that is a bit less. And I mean, who wouldn't want mug root beer, which apparently is just straight up liquefied logs? If you're going for all that, you can, but that's not me. Liquid lead works a little bit differently, however, because although it's kind of made the way you would expect it to be, it is less efficient, actually, and it reduces the core flux by 25%. Well, why would you want to do that? Well, let's say that you're running a reactor that uses one of these weird bismuth rods here, and you want a lot of them because your purpose for it is to deplete them so that you can get the byproducts of it. Well, if you're trying to use a lot of them, but you don't want to destroy the reactor, but you need to build up a lot of heat, you can use liquid lead and it'll reduce the core flux of the reactor, allowing you to fit in even more of your fuel rods without any sort of detriment to your reactor. For the sake of this, we're going to use the regular coolant. Another popular coolant is liquid sodium. Liquid sodium works kind of perfectly if you look at it. It's just a better coolant. As you can see here, it does get a lot hotter though. And see, it's very efficient for the PWR at 250%. It's also good for the ICF with the efficiency of 300%. And it just works very well. It's a very good, well-rounded coolant. But for the sake of this, we're going to use the regular coolant. So now it's time to get our basic stuff. We're going to use heat exchangers. This is one of the many sorts of things that we actually do require them. And we're just going to get these. Well, here's what you do. So here's how these things work. You open the control rods, it'll generate heat, core temperature will increase, and then that will heat up the coolant. The coolant then needs to be pumped out, which I will demonstrate like this. So this is the hot coolant. This needs to be pumped out, but it needs to cool down, and we do that with heat exchangers. Heat exchanging heater. Basically, you put in your hot coolant, and the default setting for this is coolant, but you can use other fuels such as heavy water. If you can grab heavy water, you can use heavy water, and you have to use the hot version. And now you can turn hot heavy water into regular water. The default for this, however, is coolant, as coolant is, well, kind of the baseline. So we're going to use 3 of these just to be safe, and we're going to connect every single one of these to this. Just going to heat that up there, and then also that's going to give us regular coolant or cooled coolant. So how do you get those? Here's how I do that. Go ahead and actually move that with that, and then we need to pump this back into the reactor, which will be done like so. Now, just like that, we can have this reactor running. We can have it up and running, and it won't really do anything, but we can have it running at a safe way. However, we want to produce energy with this. So how are we going to do that with those heat exchangers? Well, fortunately for us, this is kind of a bit of a utility. So we can have this for using most of the little constructs that will actually use heat in that way. So we can use this for coker units. We can have it heat up stuff like big furnaces or combination ovens. But what we're going to do is something else. We're going to have this, let's put those in here. We're going to have this with boilers. Now, I don't know if I actually really thought this through and have boilers here. So we're going to get ourselves boilers. Now, you could use regular boilers, which would work fine. Or if you're a little bit into your petroleum age, you can use industrial boilers. The only difference is that these will not explode. These will explode. We don't want them to explode. And we want to be able to leave these alone for a little bit. So we're going to take the industrial boilers. Now, the next thing we're going to need is these. We're going to go regular steam and water, as well as low pressure steam. So how these boilers work is that they only boil water to regular steam. You don't condense them unless you change it to where you can like click it like this. That turns steam into dense steam. But I mean, there's really no reason to do that, and we don't need to do that. So why do that at all? So what we're going to have is we're going to have a separate little thing here. We can have a barrel, and we're going to use the barrel to fill these up with water. That being said, we should probably also do the same thing with coolant. I'm a bit lazy, and so I'm not going to go back and grab the coolant thing. I'm just going to do that in a bit way. But let's go back and let's grab one of our tools that we have going on in here. Wherever it is. Here it is. Infinite fluid barrel. Now, of course, if you're making this in survival mode, you're going to want to actually make the coolant itself and all that good stuff. But for the sake of this, we're just going to do this. We're going to close it off. We're going to go ahead and fill these up with water. Then close it off. And now we have all the water and we have all the coolant. Now we can connect all these guys. And just like that, we have our steam. Now there's a few things you could do with this. And I'm going to show you this is what we will do. You can put those there. You can throw that barrel there. But now we need a steam engine. Now, we have a bunch of these, even the Leviathan steam turbine. But if you look at steam, and you can see how expensive these are. This one's pretty cheap. This one's pretty cheap. This one's a bit more expensive. And the Leviathan steam turbine, that takes a lot of material, even some materials that are in the nuclear age. Well, if we don't really have that, we're going to go for industrial steam turbines because they're a bit easier. And we can make a lot of them. So here's what we do. I have full faith that this will produce a lot of energy, and therefore it will make a lot of steam. And we want to have enough steam turbines to really cover it, so we're going to have 3 of them. 3 steam turbines that will produce probably a lot of energy. They're also going to connect this to low pressure steam. Well, now we need a cooling system. Now we need something to turn that low pressure steam back into water. And that's where we can go back for this. Now, of course, the next problem comes when these big cooling towers, this requires a ferro-uranium anvil. A ferro-uranium anvil requires uranium and steel. This can be pretty easy to make. You can do that for sure. But this is during the nuclear fuel processing. Which, I mean, if you have this reactor, we would have already completed that. Given that the ferro-uranium anvil is quite easy to make, given that we've already would have been there, we can go ahead and grab one of these. These are big, big towers. Now, see, to make the ferro-uranium anvil, you just need the ingots and an iron anvil. And you can do this at any anvil. Now, if you haven't started your nuclear processing yet, then having one of these big cooling towers is not going to be able to happen because you don't have uranium-238. It's totally okay if you don't have uranium-238 yet and you haven't actually started your fuel processing. but make sure you do that before you actually start building this kind of reactor, especially this one. This should be able to handle everything that we have, and now we have two different systems that will work in tandem together to create energy. We're going to go ahead and put this back. If we want something even more powerful, there is the high power steam condenser, but I don't believe that this will be powerful enough to warrant us using one. So I'll put that there. We're going to take our cables and we're going to get an energy storage block. We're going to get a strychnine energy storage block. Now, at this stage of the game, you will only have access to lithium-ion energy storage blocks, but I want something that can take a lot of energy at the moment. Lithium-ion energy storage blocks only have 50 mHs of storage. We're planning on making much more than that. Now, of course, what you can do is you can have it on for like 5 seconds, get all the energy, and then move on. But I want this to be running for a little bit so I can properly demonstrate how this works. So now we need a fuel rod. Well, if you look at our PWR fuel rods, there are a lot of options. The medium enriched uranium ones would probably be the cheapest and easiest to get, given that uranium fuel, for PWR, uranium fuel is very easy to make. If you look at shapeless crafting, all we need is uranium-238 and one little piece of uranium-235. The issue is that it's really that cheap to make. And because it's a cheap fuel, it's probably not going to make as much power as we want or as we can handle. So we're going to grab these highly enriched uranium-235 rods. Now, although it only needs 26 to be fully fueled up, as you can see, we are going to put the rest of these in here too because you need a steady supply of fuel. Yes, these are expensive to have this much fuel, but that's a small price to pay for the amount of power we're going to generate. Now, as you can see, all those are in there. If we get real close to it, you can hear that deep, deep rumbling. That is what we want. But as you can see, the flux hasn't increased. This is because all the control rods are letting 0% of flux through. So let's turn this up to 10%. That has already changed dramatically. There's a lot of fuel in here, lots of heat going on as well. And as you can see, it's actually taking a long time for this to actually deplete. This is a good stable setting. As you can see, cooling tower is having no problem processing all that. Tons of steam being produced, and we're making actually pretty good energy. Now this is more energy than our RBMK was making in their first setting. And as you can see, the two systems are working together just fine. You have the coolant running through here, and then you have that heat generated from that powering up these boilers. Well, if we have no problem with that, then let's go ahead and turn it up. Let's go 25%. Lots more heat. You can even see the coolant level dropping as more hot coolant is going through. Lots more heat as well. And as you can see, it's actually starting to deplete these rods a bit faster. We look through here. Lots of steam. These guys seem to be able to be handling it okay. And no problem at all with the cooling tower. We go down here. Lots of energy. That's already as much as the other one was making, as the RBMK. Issue that I can foresee now is there not really being enough of these guys. So to make sure that we have enough, we're going to add one extra one. It'll be expensive, but it will be worth it as you will have just so much energy. So much energy. We have plenty of energy being made. But this is only at 25%. But we're going to want to be careful because these little dials are going up, and we don't want them to reach maximum level or else the reactor will explode. So let's go to 35%, just 10% more. As you can already see, it's jumped. So much more power. And the whole heat is cooling the reactor very quickly, very efficiently. Now I can go over here. These boilers are working overtime, as you can tell. Steam turbines are working as fast as they can, and the cooling tower, of course, is no problem at all because this is a big boy. These guys can cool stuff very, very efficiently. We're very happy with those. That's how much energy we're making. That's pretty good. Like, in terms of reactors, that's actually incredible. Now, of course, the more reactors, or the more fuel rods are depleted, as you can see, these are depleting relatively quickly. The more of these are depleted, and the less there are inside, the less power there will be with the reactor. Now, the issue is you can't exactly take them out of the reactor once they're inside. The only way to actually cut them out and remove them is to either let all of them fully deplete, which would take a very long time, or you can just break the controller. And I'm going to do that for purposes here. We break the controller and then reopen it. All the coolant will be gone except however much is over there already. All the rods will be gone. And it can be a little bit of a problem to actually do that. Now, I don't know, I thought that just grab some stone for experimentation purposes. If you have your PWR fuel rods, let's say you have these guys, click 0, fill it up. If you had a pickaxe, I can actually do that, and you were in survival mode and you broke this, you will not get anything back. Everything that was inside has become void. So if you want to have to remove the PWR or take the fuels out, just be prepared for a pretty costly endeavor. I'm gonna go ahead and refill this. The steam system, thankfully, is completely separate, so we don't have to worry about any of that. It's perfectly fine. The only issue is that all our coolant and all our fuel has been voided. Once again, that's a pretty big bump. Now, as you could tell, with those fuel rods, it actually wasn't able to get to maximum power because this thing was going up a bit too high. So let's try out these fuel rods instead. We're going to start off at 25%. Nothing changed. So let's go up to 50%. The problem with these fuel rods, at least for me, is that they kind of suck. Logarithmic fuel rods, you have to have a lot more of them, and chances are if you're using a logarithmic fuel, you're going to want your core to not exactly look like what I have here. We're going to want it to look more like this, where everything is well compact and you need a lot more fuel rods for that to actually be worth having. You probably have something like this star shape, and that's just no fun at all. That's why I generally try to avoid using those. If you can tell, see, it's generating energy, but it's generating such negligible amounts of energy that it might as well not be generating anything at all. You'd probably have more efficiency running a wood-burning generator. And as you can see, even at 100%, it does go up a little bit, but it's just not good. That's why I try to avoid using logarithmic fuels, especially if you have a setup like this. This is built for square root, not logarithms. Terrible, terrible energy. That's essentially how PWRs work, and fuels. If you want to see different kinds of PWRs, I'll be keen to make that. But now that we've looked at how PWRs work, how the cooling system works and how it generates energy, and also the cross-section of a pretty basic one that's built for square root function fuels, let's look at how to actually build one. So first things that we're going to do, we're going to grab all this stuff. We're going to start with the main core, which composes of these guys. Now go to your area that you want to build your PWR, and start with the floor. You can make changes to this as you go. You build that, and then once you have the floor, you're going to need to choose a place for a neutron source. Wherever you place the neutron source should be the center of the reactor. So building this as if I were in survival, I'm going to build up, I'm going to place the neutron source here. Dang. Now this would be the center of my reactor. I can place some control rods, leading to a fuel rod, then a control rod, and then we could probably even place another fuel rod. And then I could change that for a neutron collector. When you're building and constructing a PWR, you want to start with the core and then branch out to where you want the fuel rods to be. Once you have the fuel rods placed where you think you'd be most happy with them being, then you can decide whether you want neutron reflectors or just nothing there and having just kind of like a shell. You can decide for that. And then also, once you do this, you can replicate it in an area that's right next to it a few times. Bam, 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 boom, bam. Just like that. Replicate that a few more times, and then you can also decide what's going to go in between them. Probably control rods. So, and then after you build something like that, you can go all the way back. And that's where you can start whipping out your coolant channels and heat exchangers. Once again, you can place them however you want to. I like placing heat exchangers in between these and then having the coolant channels on the outside, just as long shafts where the coolant will be. Once again, you can build these however you want to. This is just my general construction tips on building a room. Now I can tear all this up. Every single time I keep putting with difficulty to peaceful. Those guys keep spawning. Why do they do that? Terrible. Terrible, terrible things. I'm just gonna go ahead and clean up all this. There you go. And that is PWR basics in construction. Once again, if we're using something like, why do these guys always be here? If you're using something like a logarithmic fuel, you should probably have a coolant that will actually benefit from being that kind of slow, and that would be heavy water. However, you could use thorium salt. Now, I did already discuss everything kind of about this and the basics of it, but something that I want to mention, kind of like as an honorable mention, is liquid thorium salt. This is a completely different, this will basically turn the reactor into a thorium salt reactor rather than a PWR. There is no clear distinction in this game between the two, but thorium salt works a lot differently than other coolants. See, with most coolants, you just take your heavy water and then boil it, or whatever coolant you have. You'll get the hot version of it, and then you cool it back down into what it is, run it right back into the reactor. Thorium salt doesn't work like that. Thorium salt, as you can see here, in order to make it, you need to put thorium powder and chlorine gas, very toxic gas. Then you get your liquid thorium salt. Now, when you heat up liquid thorium salt, as you can see, it has a very powerful PWR flux multiplier of 150%. For a PWR coolant, it's much, much more powerful than what you would regularly have. But thorium salt reactors work very differently. As you can see, instead of just having thorium salt and then hot thorium salt, you also have depleted thorium salt. When you build a thorium salt reactor, which is just a PWR running with thorium salt as the coolant, you need to be a bit more careful. The construction of that will look differently. I'll get into that on another video. But just know that there are different layers and you can't just have the thorium salt run in, hot liquid thorium salt go out, and then get your liquid thorium salt back. Things work differently. And I'll discuss that on a later video. For now, be careful when dealing with your reactors, drink water, eat some food, hug your friends, have friends, do something like that. And I will catch y'all in the next one. Y'all guys have